Hello and welcome everyone. In this video, we'll be taking a look at a full state managed LangGraph example. But before we dive into it, let's take a look at a very simple LLM interaction that you will have. So you as a user, you will have a question asked to an LLM. For example, tell me the time, or what is the weather, right? A simple question you may ask to the large language model. And the large language model, based on its text generation capabilities, will generate one prompt or the other, right? It will say the system time is 2 p.m. And even though it will not know the time right now, it will attempt to generate the time. If you'll ask weather information, it can either just make up and hallucinate and say something that it is raining, or it can just also say that I do not have that information available if it is a smart LLM. So either way, one way or the other, when you ask a question to a large language model, your LLM sends you the response back. And that's the default behavior of any large language model, right? In an agentic workflow, we try to overcome such scenarios. And this is one of the scenarios that I will show today as a large language model self-correcting scenario where we will use a large language model to analyze its final answer and then check whether it is good enough to be sent back to the user or not. And we will use LangGraph for this example, right? So let's take a look what we'll be building today. So we will be building an agent where the user, similar to the previous scenario, will ask a question. But instead of question being directly asked by the large language model, the question will be received by this agent. And what this agent will do is it will first attempt to answer the question via LLM. Right? So for example, if the question is, tell me a joke, then the agent will create a joke. It will generate a joke. It's a text generation agent essentially. So it will generate a joke via large language model. And it will then send this joke that it has generated to the large language model for evaluation. And again, so there are two large language model interactions over here, which is key. The first, where an answer is generated, and second, where the large language model checks the generated answer with the question that was asked, right? So we pass in the original question and we pass in the generated answer, and we make the large language model check whether the question that was asked was answered or not. And if the question that was asked was answered, then we send the response back to the user. Whereas if the question that was asked was not answered, then we just send back the response back to the agent, and we have the agent loop through till the agent answers the question, right? So in this scenario, we can also give an agent some kind of tool for it to use. For example, when the user asks the question, what is the weather in Woodbury, Minnesota? In that case, if the LLM has capability of utilizing certain tools, then we will make the large language model utilize those tools, right? So we will have the LLM get to use those tools, generate a result based on the tool, and then pass it along to the next section over here to make the LLM check. And this is what the LangGraph agentic flow we will build today. So we'll have the user ask a question like, what's the system time? The agent will use some kind of tool to generate the system time, and then the system time that it has generated will be passed on to the next step, and the original question will be compared with the generated answer, and only if the answer is accurate, then it will be passed on to the user. So this is the workflow that we'll build. Let's take a look at how it will look like in LangGraph scenario. So we'll build two nodes in LangGraph, right? One of the nodes is an agent node, and second node is an action node. And if we compare this with our example over here, so let me try to see if I can get both these next to each other. And okay, so in this scenario, the left hand side is our LangGraph nodes and the right hand side is our logical distinction, right? So this agent node over here is just a simple generation of prompt over here, that whether when we are asking the user to when the user is asking a question over here, then this initial generation of the prompt is what this agent is. So this box over here where we have this initial generation of the prompt is what this agent is. And the tool use is this second action, this second node over here. So there are two nodes, agent and action, and these two nodes are this box over here. Well, it looks like it's a big box, but just this small box over here, this is the agent, and tool use is this action over here. Now this decision making thing is this continue or end, right? So what happens in LangGraph domain is that we first have the agent answer the question via LLM, and then we check whether the generated answer is good enough or not. And if the generated answer is good enough, we end. If it is not good enough, then we see whether we can use a tool to generate an answer that a tool can generate, which agent couldn't generate. And then we pass it back to the agent, and then we make the agent evaluate whether the generated answer was good or not. And then based on that, we go either to the end node or we continue in the same loop over and over again, right? So it's the same workflow that we have generated over here is what we have on the left hand side. So let's take a look at the code and it'll make more sense. So in this LangGraph example, I'm also going to use the term color. So the output that you will see, it will correlate with certain color schemes. So it's a very like nice and cool tool for us to use. So I highly recommend all of us to, like start coloring and making our terminal prompts look really pretty. All right. So in this example, we'll be using two tools that we will make our large language models aware of. So what are those two tools? We have defined those two tools in this tools.py file over here. So in this tools.py, we have get current weather tool and we have get system time tool. And by annotating it with @tool annotation, we are able to extract the schema of this over here and pass it to large language model. And we'll see how we can bind tools for any generated function over here, right? So these are your two custom functions. One custom function is get current weather, and the second custom function is get system time. There is a docstring for this function and some implementation of this function. In our case, it is just randomly generated and then again randomly generated system time. So we don't care how or what the implementation of this is. It is just a mock implementation with some random data over here. But what we do care is the inputs, the outputs, and also what this function actually does, the docstring over here. And defining this as @tool, this is most important. So for us to do this, we have to import LangChain core tools over here. So very important part, but define all your custom functions in one file over here. And then you'll be able to import your two custom functions over here. So from tools, which is tools.py, that's why it is called tools, you are importing get current weather function and get system time function, right? So get current weather and get system time is what you are importing over here. Now, once you have imported these two tools, you can create your model over here. So in my case, I have my large language model hosted in my basement server. This is the the domain for my basement server, and 11436 is the port where I have hosted my server. If you want to know more details on this, I'll have the link down below in the description why it is 11436 and not the regular 11434. And I'm using the Llama 3.1 70 billion parameter model. And if you want to see why it's 70 billion parameter model, I will post a link to that in down below also. The comparison and the shocking results that I received with 70 billion versus any other model that I've seen. So highly recommend to take a look at that video too. All right, so once you have your model created over here, you can then use model with tools by binding the tools to your model, right? So you have these two tools that you have already imported. These two tools already have @tool annotation, which is important over here. And if you have done all that, if you have these two tools annotated with @tools, then you can bind those two tools with the bind tools method over here on the model, right? So this is Ollama function, which was an experimental feature that LangChain had introduced, and I go into detail in my previous video in function calling video. So now once you have generated your model, once you have bound tools with the model, and you have now model with tools, you have to create tool mapping, and this tool mapping is what you will need down below later on for you to actually execute the tool. So this is not needed right now, but you will need this when you are executing the tool. Okay, now you're going to have two different prompts, right? So why two prompts? So if you see, there are two LLM interaction. One LLM interaction is for generating an answer to the question, and second LLM interaction is checking whether the question was actually answered or not. So these are the two LLM interactions, and we'll be generating two different prompts for this purpose, right? So one prompt, which is the top prompt over here, so generating the answer to the question, is this one, the first one, agent request generator prompt. And if I scroll down just a little, and I'll go over this too, but if I scroll down just a little, there is a category generated prompt, which is nothing but letting us know whether the output category is true or if it is false, right? So if it is true, then you can just go back and you can say that, yep, the question is answered. And if it is false, then you have to go back into the loop and keep on answering the question, kind of thing. So that's why there are two different prompts that you will see in this example. Okay, so let's go back to the top prompt, the first prompt, and the agent request generator prompt. This says that you are a smart agent and you're master at understanding what the customer wants. You evaluate every request and utilize available tools if you have to, right? So I've realized that if the system prompt contains this thing, that you have some tools available with you, and because we have already bound some tools with the model, so this kind of it goes hand in hand. When you let the model also know that you have tools and you bind the tools with the model, then it makes an attempt to see whether it has to use some tool or not. And then this is where the end of the token happens. And then the user prompt is conduct a comprehensive analysis of the request provided, and you can provide an initial question over here. So you pass in your user request as an initial question being a variable, and we'll see how we are using this later on. But this is how you generate your prompt with one input parameter as a variable, which is your initial request. Then because we are using LangChain framework, what we can do is we can chain your agent request generator prompt with model with tools, and you have an agent request generator runnable available to you. So anytime when you do an invoke on this, you can pass your initial request along with doing the invoke, and here is an example that you can pass in an initial request. And if your initial request has a question like what is the weather in Woodbury in Minnesota, your agent will respond back with either an answer or a tool call answer, right? So a tool call answer means that it is going to see whether some available tools can answer the request, and if they can, then instead of just having a full-fledged AI response, it will just include a tool call response in it, and we'll take a look once we run this code. All right. Next step is we are going to use Pydantic schema for structured response. Why? So let's take a look over here. The response from this particular LLM output over here is a Boolean response. It's either yes or it is a no. Like if we send this question to an LLM that, hey, can you check whether the input question that was being asked was answered by the agent? Can you tell me whether it is yes or no? And if the large language model, instead of saying yes or no or a Boolean response, it just starts saying, oh yeah, I think the question was answered, or maybe it was not answered, right? If it starts generating a more conversational answer instead of saying yes or no, then we won't be able to make this decision over here. So we want to make a Pydantic, schema over here for a very structured response, and I'm just calling it a class evaluation, and there is a result which is a Boolean over here, right? So it's either true or false, but I wanted to make sure that I force the large language model to only say true or false, right? And I'm calling this as a category generator prompt. So the category being a true or false category, right? So it's just the name I chose, doesn't matter what name we take over here. But in the category generator prompt, which is the prompt for this particular box over here, this decision box over here. So the prompt is that, hey, you are a smart router agent and you are master at reviewing the original question that customer asked and whether that was answered in the tool response or not, right? So you understand the context of the question below and return your answer in JSON. And the answer that you're going to return is either true or false. So over here, we are now forcing the large language model. Well, this is just a suggestion, right? We are saying that, hey, use true when the initial request appears to be answered by the tool response, and send false when the initial request is not answered by the tool response, or when the tool response is empty. And this is very important because very first time when we do an evaluation, the tool response is empty. There is no tool response. So we'll see what this means, but this section is very important because this is for the very first flow. If the tool response is empty, then it returns false and it makes the large language model go into that loop again. All right. Oops, we don't want to do that. Okay. So and then we give it like a sample over here, so like some examples how it has to respond back. And this one takes two inputs. First input is the research question and second input is the tool response, right? So it has two things as an input. First is the research question, right? So original question, and second is the answer generated by this agent over here. So it's either the tool answer or the AI answer is what it is. Okay, so now we create a structured LLM, which is model with structured output, right? So what we are saying is that instead of you just generating any response, right? We are forcing you to comply with the Pydantic schema that we have, which is the evaluation class, right? So we created this evaluation class over here, and we are forcing the large language model to follow this particular schema once it is responding back. So you saw two different ways in which we can use this, right? So we had model dot bind tools, right? So we had model with tools where we bound certain tools to the model. And then in this section over here, we have model with structured output, right? So in this case, we don't care. We don't want to use a tool over here, right? When we are making this evaluation, we don't want to make use of any tool. When we are making an evaluation, we are just using the brain power, the 70 billion parameter reasoning power of large language model. So we don't need to use any tools over here. We just need to get a structured output, right? So what we are saying is that model with structured output, use this particular evaluation, the pydantic schema as your structured response. And then what we are saying is that, hey, take this category generator prompt and chain it with your structured LLM, which means that you can only respond back with this particular model type. And then we are creating our runnable over here. So the category generator runnable dot invoke now will take in 2 inputs, right? Because this prompt takes in 2 inputs, research question and tool response. So let's see. So here's an example. So we have a category generator dot invoke. Research question is your research question over here, and tool response is a sample tool response that I have sent. And you can run this over here to see how this particular prompt behaves. So this is something that I normally do. I just while I create a prompt, I just invoke it just to check whether this prompt is working or not. And I pass in multiple different kinds of research questions over here or input parameters just to check whether this prompt is working or not. All right. The next step over here in any kind of agentic flow is that we create an agent state. So what is an agent state in this diagram? So I've not really depicted it, but in general, an agent state is like a state of the whole flow that we are maintaining, and we are passing along throughout the whole flow over here. And you can choose to have whichever variable that you want to have all the flow items available. So for example, in this case, I'm saying that research question, right? So this is something that I want to be part of the one second, please. I want it to be part of the agent state, right? So research question, which is the initial question. Then I also want any tool response as part of it. I also want agent response. So if agent has responded back, so I want that over here too. So let's do that. And agent call count and tool call count, right? So those 2 things as well. So, and agent call count and tool call count, I'll show you what they are. But this is something that I kind of keep track of so that I can see how many iterations are happening while I'm running any kind of workflow over here, right? So agent call count is how many times this agent was called. Like if it gets stuck into multiple different loops, like hundreds of times it's running, and I don't want that because agent operations can sometimes be expensive, then I can put a cap on it. Maybe in this particular check, I can say, hey, if the agent call count has surpassed beyond 25, then stop. Right, and then we can send the answer anyway to the user. But it's good to see the agent call count in your state. But what state means? So this particular thing is your state. STATE, your agent state, and your agent state is modifiable and available throughout your agentic flow. Right? And this is the reason why we can extract this research question out. We can give it to this particular section over here. We can extract the tool response, agent response, and give it to this. Or we can regenerate any question any response back again, and we can have the whole history available to the agent while it is responding. So any kind of correction that if we want to make, all those things can be done if we have a state available to us. So this is what we're doing, and you can choose any variable you want to keep in the state. You're not limited to it, right? Any variable that you think, like I just wanted agent call count, so agent call count, so I chose to just keep it in the state because why not? So that's the thing. So you can just define any agent state over here, and you can choose to have any variable in the agent state, and having a type dict really helps because then you can not have, you know, like the runtime errors. You can see the compile time messages over here when you're trying to assign variables. Now this is where you have to define your two nodes now, right? So your first node is an agent node, right? So let's take a look at this diagram. This agent node and action node, these are the two nodes that we have to define. And your conditional node is also something that you have to define, because these conditions are also defined as whether you want to go from agent to action or you want to go from agent to end. So these three things that we have to define, which I'll do next. So agent, action, and conditional. Okay, so if you see, the very first one is agent. So in this one, what we are doing is we are passing this agent state, right? So we pass the whole agent state over here in this node. And what we say is that go ahead, do whatever you want to do in there. But if you are returning the data back, right? So you can modify this state object. So you'll see that I'm doing some operations over here, which I will go through. But while doing these operations, the key is that I'm modifying this state object that I have passed in. And while I'm modifying the state object, I'm at the very end passing the state or returning the state object out too. And you will see this theme going on, right? For any node. So for any node over here, so agent and action, these are the two nodes. For any two of these nodes, you will take in state as a request and you will output state as a response, right? So this is key. State comes in as a request and state goes out as a response. If for action, the same thing, you will take in as a request and you will return state as the response back from here. So all these nodes do that, except the conditional, right? So these conditional routing elements only take in the state as an input. However, they do not spit out state as a response, because the condition, these arrows have to spit out which particular node do you want to go to, right? So you have to say either continue or end in this scenario. And that is why these do not take in these do take in the state, but they do not spit out the state back, but they give you back the actual node you have to go to. And we'll take a look over here in the example too, so it will make sense. So for agent, we take in the agent state, and then I'm just printing out the initial agent state over here. And then what I'm doing is I'm actually taking this agent request generator and I'm running an invoke on it with the initial question, right? And how am I getting the initial question? I'm extracting the initial question from the state, right? So if you take a look at this diagram again, so I'm taking the initial question from the state over here. So I store the initial question at the state and I am passing the state over here, and I'm extracting the initial question from the state and passing it to the agent request generator runnable, right? And the output of this would be either a tool call or an actual response. So if it is a tool call, then your next step would be that you'd either go to the tool call node if there is a tool call involved, or you will just say that there is no tool call involved and go to the end, right? And that's the logic which is in should continue. But in the agent node, what we are doing is we are passing in the initial question, and the initial question is being answered by LLM in one way or the other. So let's take a look at this diagram. We are passing in the initial question over here, and this box is actually saying that, hey, let me attempt to answer it, which is this line over here, right? So last AI message is the response that I'm saying we are getting out of it, but this is what this box is doing. You are answering the first question over here in the last AI message, and if you have answered that, then you are changing the agent state, right? So you are changing the agent state, and you're saying that, hey, the agent response is the last AI message, right? So we are modifying the state over here. So we passed in the research question, and we are modifying the agent response. And that's how we are proceeding over here. If the tool call was obtained in the agent response, then we are populating the tool call content also over there. So we are modifying the state again if that is happening over here. All right, then we go to the next flow. So you see that from actually this one. So once an agent has been processed, you go to should continue node, right? Because you have to now make a decision that whether you have to go to action or you have to go to end. So this is why you go to your should continue condition over here. And in this should continue condition, you take in as an agent state, but you return back either end or continue, right? So this is key. You take in as a state, but you don't return the state. Whereas for nodes, you take in a state and you return the state, right? So there are two nodes over here, agent and call tool, right? So there are two nodes, agent and call tool, which are represented over here. Agent and action or call tool, same difference, but there are two nodes, agent and call tool node. Both of these are going to take state in as an input, and both of these are going to spit out state as an output. So, but the only difference is that if you are done processing with your agent and you're going to should continue condition is either going to spit out continue or end, right? And which is what is happening over here, continue or end. So it takes in as a state, but doesn't spit out the state. It spits out the continue or end part of it. So when we are taking the state from there, we are trying to extract two different things. Initial question, right? So we are extracting the initial question, which is the research question from the state, and we are also extracting the tool response, right? So tool response was set in the previous agent in the state. So we set the tool response based on the last AI messages content. And if the tool response was set over here, then we take the initial question, we take the tool response, and we evaluate it. So we use the category generator, where you remember we had the structured response, and this would return either true or false based on it will return the evaluation object, and the evaluation objects, we will retrieve the result of the evaluation object, and if the result is true, then we say that, okay, if the result is true, then we go to end because the question has been answered. And if the result is false, then we continue because the question has not been answered, right? So if we take a look over here, if the question is answered, if the result is true, we end it and we send the response to the user. If the question has not been answered, then we go back to the agent and we make the agent respond back, right? So that is the should continue piece of it. And then the call tool is the actual tool call, which if you see in this example is called as action over here. And this is the actual tool call where it takes in as a state and then it spits out state as a answer. So in this particular node, you'll see that no LLM call is going on over here. All it is doing is it is extracting the agent response, and it is seeing that, hey, if the agent response has a tool call in it, then just take that tool call and process the tool call, right? So it will take the tool call, and you can take a look at the function calling examples that I had, the video that I made before, how you process a tool call. So in this case, we extract the tool call, and then we take the tool call mapping object, so which is the tool mapping object. We extract the tool call's function name, we extract the tool call's arguments, and then we increment the tool call count in the agent state, and we execute the tool call over here. So we invoke the tool call, and we increment the agent state. We print all that out, and that is it. That is it. So we have three different functions that we have defined. One is an agent, second is a should continue, and third is a call tool. And now let's create our nodes, right? And we will create our conditional edge. So these two nodes, agent and call tool, will be created, and the conditional edge of should continue will be created over here next. So we create a workflow. In the workflow, we say, hey, this is a state graph, and we associate agent state to it. In this workflow, then we add a node called agent, and we associate the agent function over here. And remember, the agent function takes in as a state, and it returns back the state, right? We create another node, which we call as action. We associate the call tool function to it, and the call tool function takes in agent as a state and outputs agent state 2. However, the conditional edge does not output the state. It does take in the state, but does not output a state, right? So if we hover over should continue, we say that it takes in the state, but it outputs either end or continue, right? Which is the key, because a conditional edge will never output a state, but it will output an actual conditional edge condition over here, either end or continue. So we add two nodes. We set the entry point as agent, which means that at the start, the entry point is agent over here. And we are going to add a conditional edge over here. And we are going to have a direct path back from action node to agent. So action can never result in end. Action will always go back to agent. Why? Because any action that has been generated, right? So let's say if we asked a question, what's the weather? And the LLM has responded back. So we want to make sure that it goes back to agent, and agent sends it back over here for evaluation, whether this answer was good enough to be sent to the user or not. So only after that evaluation happens, we can send it to end. We will never send an action result directly to end. All right. So our workflow is straightforward and simple. We created two nodes. We set an entry point. We put a conditional edge. Conditional edge says that from agent, we can either go to continue or we can go to end, right? So if we are continue, then we go to action. And if it is end, then we go to end. So this is what this diagram is saying, that, hey, from agent, you go to continue or you go to end. So let's see where this arrow is. So something from action needs to go back to agent, and we should have action going back to agent also here over here, which is this. Perfect. So now we can compile, and this is a small helper method that outputs this output 5.png, which is what we've been looking at. So this is generated by this program itself. This is pretty cool feature of LangGraph that it generates it. Now I'll be taking 4 different examples over here, right? So I'll have 4 different research questions, and we'll see how the whole LangGraph scenario plays out for us with these 4 questions. Okay, so the question number 1 would be the simplest question, tell me a joke. And we will create an initial agent state. And in this agent state, we'll create everything as empty, but we'll populate just the research question. And we will see how the agent state gets modified throughout the flow, right? So throughout the life cycle of this agentic flow, how does the agent state get modified, which is what we will take a look at with each one of these 4 questions. So question number 1 is, tell me a joke. So what we are doing is we are going to do app, which is our workflow compile, right? Workflow.compile is the app, and we will do app.invoke and we'll pass in the state, right? So if you remember, we set the entry point as an agent. So when we say start and when we say invoke, we are actually passing the state object to this agent node over here, right? So enough of that. Let's go over here and let's run this. So I will do Python, and this is 05, and that is it. All right, so once we start running this, actually there will be some initial load that will happen because this is a 70 billion parameter model. This very first time when I hit it, it is gonna load this model into the VRAM of my 2 GPUs over here. So this is my AI server in the basement. It has 4 NVIDIA 3090 graphics cards, and you will see that once these 2 numbers change to 21 or 22 approximately, that is when the whole model is loaded into the VRAM. But while that is being loaded, I want to show you this over here. Let me see if I can make this bigger. Okay. All right. So can I? Let me see. Okay. This is better. Okay. All right. So what I've done is all these messages, they are coming from our, at different stages, I have made the program pause. And I've done it so that I can hit enter and continue, and you guys can observe how the state changes. So at the very start, we just had the research question, which is tell me a joke, right? And everything else was set as empty. So if you remember, I was showing you this was the initial agent state for us. So once we had that, I hit enter. So we went inside the agent and the first LLM interaction happened. So when I said, tell me a joke, the tool response that I populated in the state was the direct message from the agent, right? So because agent had a content back, I'm populating it back as a tool response from the agent. And it says, I'd love to share a joke with you. Here is one. What do you call a fake noodle? An impasta, right? If I hit enter over here, now we go to the should continue logic. And so in this case, agent has generated the answer and it is now going over here. So we are paused over here. Now it is going to the should continue logic. So I hit enter and now it is evaluating. Now it is in here and large language model is evaluating. So this is the evaluation where it said that, hey, is the tool response good enough and should the flow go to end node, right? So this was the tool response and this was the initial question. And what the large language model decided that, yep, the tool response is good enough and you can proceed to the end node. And then this is the final state. We return to end and the final response at the end is this particular response, right? So let's run this again and let's see. So this is the initial question. So the state at the start, tell me a joke, and we go to the agent. Agent attempts to respond back to this and it generates a response which we assign to the tool. And then if I hit enter again, it is at the start of the should continue logic check, and I hit enter and it says that, yep, looks like the question has been answered. So we can go to the end node and it goes to the end node. And then this is the final state at the end. And this is the final response at the end. And this is pretty cool, right? So it it is able to answer our questions, and then it is also able to go back into the kind of like a self-reflection and check whether the question that was asked was answered or not. And if it was, then it says that, okay, let me evaluate it. It is answered, and let's go to the end. All right, so we saw that in a simple example, it works out pretty good for us. So let me comment out that, and let's go to a different question over here. What is the cause of earthquakes? Let's send this as an initial question and see how the agent responds over here. So this is the agent state at the start. What is the cause of earthquakes? So if you notice, agent is not making use of any tools. So there are only two tools that the large language module has available to. So those are get weather and get system time. And LLM hasn't determined yet that this question requires use of those tools, right? So LLM is saying that, even though I have tools available, this is a question that doesn't require tools. I can answer it by myself, and which is what is happening. So if I hit enter over here, we go to the agent's initial processing, and agent was able to answer this. And if I hit enter over here, we are at the should continue start, and then it is evaluating whether the initial question is answered by the tool response, and it determines, so it ends it. And this is the final answer to our question, which is earthquakes are caused by the movement of tectonic plates and all that. And it believes that this is a good answer to be sent to the user, which is pretty cool. Now let's send a different question, which will invoke a tool response, right? So a tool response means that it cannot just end the query after the initial request, right? And it will make sense once I run this agentic flow. So now your first initial question is, how is the weather in Woodbury, Minnesota today, right? How is it? And to answer this question, the very first time, agent will say that, probably I don't know the answer to it, but I do have a tool available to me. So let me just say that if you run a tool, you can get an answer to it, right? So let me hit enter and see what the AI response is over here. So the response that AI has is, so if you take a look at this AI message, the response is that, hey, there is no content, right? So the content is empty. And that is why I have assigned the tool response to empty over here. So the content is empty. However, the tool calls section says that, hey, if you run the get current weather tool with the arguments Woodbury, Minnesota, then you will be able to get the answer to it. But as of now, I cannot answer it, which is pretty cool. The agent determined that a tool needs to be run. However, it is saying that unless and until you run the tool, you won't be having the answer with you, right? So we are at this stage. What we are saying is that, hey, go ahead, evaluate whether the tool has been run or not, right? This is what the evaluation will happen over here now. So if I hit enter, it will take the tool response, which is empty, and it will compare it with this. How is the weather in Woodbury, Minnesota? And it will say, the response is empty. So you should go back and you should process the tool response over here. And I'm going to hit enter, and this is where we are at the start of the should continue. If I hit enter again, it is evaluating whether the empty response has responded with the research questions answer or not, which is false. Nope, it has not. You cannot go to the end node is what it is saying. So I hit enter, and now we go to the call tool, right? So this flow was not being invoked when we were asking simple questions. So maybe you can pause the video over here, go back and see the flows when I asked, hey, why do the earthquakes happen? Tell me a joke or something. You will notice that the call tool was never being invoked. right? But now that it realizes that, okay, I have not been able to find an answer because the answer is empty. So let me go back and run a tool. So this is where it runs a tool and the tool responds back, which I populate over here in the state. And because I have populated the value, now when I go back to the agent, right, the flow goes back to the agent. So which is this section over here. So let me show you that after the tool call has happened, the tool call will always go back to the agent, right? So this is the flow that is happening right now in our diagram. And so it went back to the agent over here, and now agent is going to execute that, hey, let me check again. And what we are getting back is that, hey, there is a tool call, there is a tool response, and let's go to the should continue logic. And the should continue logic will now check this initial question with this answer over here, right? So we go back over here, it is evaluating whether this thing is the answer to the original question, and yes it is. It found out that, okay, yep, you can go to the end node now because the question has been answered. And if you go over here, the final answer is Sunny, right? So this is pretty cool. So now we are able to execute a flow where we can invoke the tool call. So let me comment this out and let me uncomment this, and let's see if the system time tool gets invoked over here or not, right? So if I go back to the terminal, you will see in the previous example, the tool call was get current weather. In this example, we are expecting that the system time tool will be invoked over here, and let's see if it does. So this is the initial state, and we are at the start of the executing agent logic. And over here, the state has been modified. Again, the tool response is empty because the AI message says that, hey, the content is empty. There's nothing over here for you. However, if you run the get system time tool, then you will get that answer over here for you. So I'll hit enter over here. And now it is at the should continue section over here. And it is evaluating whether the empty response is the answer to the current system time, and definitely is not, saying that do not go to the end node, you have to go back into the loop and you have to run a tool. So it goes to the call tool side of it and it tries to run the tool, and it has received a tool output over here, which has been populated in the tool response. And now we go back to the agentic flow, and in the agentic flow, we check whether the question that was originally asked in the should continue section is answered. And yes, it is this time, because the tool response contains the answer to this question, right? So now it just goes to the end, and this is the final state, and it is the final response at the end. So something that you will notice that the number of iterations that happened, there were 2 iterations for the whole thing, because the agent call count is 2 over here, but you do indeed get the final response at the end. So this is a very simple example for an agentic flow where the agent can reason with itself whether the answer that I'm producing is correct or not. And you can force some kind of pydantic schema, and there are multiple different small little things that I have shown you guys over here. So the very first thing that I show as a summary is how you can create your custom tools, annotate them with the tool annotation over here, and then you can bring them back and you can bind tools to your LLM, right? So this is the very first part of it, what I showed to you. The second one was how to generate different prompts. And in one kind of prompt, you are generating it for doing a tool call. So this is a tool call prompt over here. And the second kind of prompt, you are generating and you are binding it to not just like a simple tools, but to a Pydantic schema. So you are creating a Pydantic schema over here, and you're binding your large language model to respond back in that schema. And then you're generating your agent state. State can have anything you want to go in there. It doesn't matter. You can have anything and everything. And this is pretty cool that you are not forced to pass the whole state to large language model. You can pick and choose whatever you want to pass to the large language model, right? Then you can define your functions, which you will associate to either a node or to a conditional arrow, right? So you have three functions that you have defined: agent, should continue, and call tool, right? And these three functions are then associated in your state graph. So in your state graph, you define two nodes, you define the entry point, you define the conditional edge, and you then compile your graph. If you want to see how it looks like, if you want to visualize, there is a small helper method over here. And then you create your agent state and you invoke your agent state. Very simple, straightforward example, but it's a solid entry point for you to learn how to use LangGraph. I hope you like this video. If you have any questions or comments, please leave them down in the comment section, and I'd be very happy to take a look at them. Thank you everyone for watching this.